Hi, so for today we're going to talk about Doolittle's method. This is another method used to solve systems of linear equation, but using LU decomposition of matrix. So from the previous video, we have tackled all about Gauss-Jacobi and Gauss-Seidel. So this is another way of determining the unknowns in a given system, systems of linear equation. Okay, so Doolittle's method actually basically has 3 steps. Okay. So we have the first one, the matrix L multiplied by the matrix U is equals to the matrix A, wherein matrix L is our LU decomposed matrix, of which our L is composed of 1 diagonals, and all the elements below the diagonal is non-zero, and all the elements above the diagonal of this L matrix are zeros. And for U, we have diagonals that are non-zeros, and above that diagonals is actually non-zero, and below the diagonal of this U are zeros. So matrix A is the matrix form of the coefficient of the unknowns. Later on, we will be uh, uh, having some examples, okay, so that you can see. So step 2 is actually the matrix L multiplied by matrix Y, wherein Y is an arbitrary constant for back substitution. Okay, and that is equivalent to the matrix C, wherein matrix C is the matrix form of the constants of each equations. And for last step, we have U times the X, okay, the matrix U times the X, wherein yung X natin is the matrix of the unknowns, and that is equal to the Y, of which we have discussed it a while ago. That is the arbitrary constants for back substitution. So basically, let's have a 3 by 3. Okay, let's say we have an example of for 3 equations, 3 unknowns. So we have here the values of the matrix form of L, the matrix form of U, and the matrix form of A. We said that L multiplied by U is equals to A, wherein our L, as I've said a while ago, is an LU decomposed matrix, wherein its diagonal is composed of 1, and above those diagonals the other elements are 0, but below the diagonals of this one are non-zero elements, L21, L31, L32, which means the element L in row 2, because this is row 2, column 1, L21, L31 is row 3, column 1, and L32 is row 3, column 2. Okay, the same for U, but the difference is that in the U matrix, we have a diagonal that is non-zero. We call it U11, U22, and U33 to denote that it is its position in terms of row and columns. So we have here below the diagonal, the non-zero diagonal are zeros. The elements below them are zeros. And above this diagonal are also non-zeros. Okay? And that is equivalent to A11, A12, the matrix form of A, A13, A21, A22, A23, A31, A32, and A33. And this is basically valid only for 3 by 3 matrix. Okay? So, for example, we are given for this equation. This equation is the same problem or given that we have used to solve in Gauss-Jacobi and Gauss-Seidel on our previous video. So here, we don't need to arrange this equation in diagonally dominant. We just leave it as it is. So solve for x, y, and z of the given systems of linear equation. So what are this matrix A? Actually, if we're going to put this into matrix form, we'll be having an equivalent matrix of this. Well, of course, I forgot to add here the x, y, and z. So we have here, this will be x, y, z multiplied by that matrix is equivalent to that. So we have here the elements, the coefficients of the each equation. So we have here 4, 22, negative 13. That corresponds to A11, A12, A13. And A21 corresponds to 19, A22 corresponds to negative 13, A23 corresponds to 4, A31 corresponds to 8, A32 to 8 also, A33 to 17 also. And well, of course, this is our matrix C. Okay? this will be our matrix C, the constants of each of the equations. Okay, so how do we solve these systems of linear equation using Dolittle's? So our first step is actually the matrix L multiplied by matrix U is equals to the matrix A. So what are we going to do? So first, in multiplying matrices, we have to get first the A11, okay? So we have to derive an equation. Well, actually, to find the unknown values of L21, L31, L32, U11, U22, U33, U12, U23, and U13. Okay, by this relationship, L times U is equals to A. So matrix. So if we perform multiplication on this matrix, so let's start with A11. So A11 is simply equal to what? Row 1 of L and column 1. Okay? So we multiply matrix by this. The row 1 of this L and column 1 of this U. So we have what? Row 1, 1 times U11. Okay? 1 times this. Plus, of course, plus 0 times 0. Multiply this element by this element. 0 times 0, 0. Plus, multiply this 0 times 0 is still 0. So, plus 0 times 0. So, in other words, U11, which is our unknown, is only equal to A11. Okay? So, have you followed? Yes. It's really hard for the first time, but as long as you follow the multiplication, okay, technique, you'll get used to it. Okay? So we have U11 is equals to A11. And what is our A11? Of course, this is our A11. So simply our U11 is equal only to 4. Okay, let's proceed. So let's now get the A12. Okay, how do we get that? So of course, the same process, A12, we have what? The row 1, still the row 1 of L and column 2 of the U. So it turns out that that should be 1 times multiplied by 1 times U12 is U12, okay? Plus, of course, the other elements here, this multiplied by this is 0, and this multiplied by this is 0. So simply, we have this plus 0, or in other words, A12 is actually equal to U12, wherein our our unknown here is U12, that is equal to A12, and what is our A12? In this case, that is 22. So we have here 22 yung U12. Okay, our U12 is 22. So let me just box that. Okay, how about A13? So what are we going to do to get A13? Well, that's easy. A13 again, row 1 of column L, the row 1 of column L multiplied by the row 3 of column of matrix U. So we have L multiplied by U13, that is simply U13. Okay, and if you're going to notice, 0 times U23 is 0, 0 times U33 is 0, so we are left with U13 is simply equal to A13, which is, A13 is what? Negative 13, according to our matrix. This is our A13, row 1, column 3. So we have negative 13 here. Okay, so 6 more to go. We have to get A21. Okay, our A21 is basically the row 2 times the column 1. So we have here row 2 times the column 1. So L21 times U11. Okay, L21 times U11. L21 times U11. 1 times 0 is 0. 0 times 0 is 0. So we are left with this equation. So our unknown here is basically what? L21. We don't know L21. So to get L21, we have A21 over U11, of which our value of A21 from the matrix is 19. Of course, that is 19. Our value of U11 is 4. So that would be our value of L21 for now. Okay. So how about if you're going to get we're done with A21. Okay, we're done with A21. We have to get A22. Okay, so A22 using the relationship for that, we have A22 row 2 of L times the column 2. So we have L21 times U12 plus 1 times U22, okay, plus 0 times 0 is simply 0. So we have L21 times U12. So L21 times U12 plus, we have L21 times U12 plus simply 1 times U22 or simply U22. Okay? So our unknown here, well, of course, is I think U22. So we have to arrange the equation so that we can get U22, and U22 is simply A22 minus L21 times U12. And A22 from our matrix, again, A22 from our matrix, A22 is negative 13. So we have let's write it here, negative 13 minus L21 is 19 over 4 times U12, our U12 is 22. Okay, so we're going to compute that for a minute or for a second. 19 over 4 times 22, that should be negative 117.5. Negative 117.5. So that is our U22. Okay, and again, how many more to go? So we have A23 in this case. So we have to solve for A2. Oops. So we have A23. We have here A23 row 2 of L and column 3 multiplied by column 3. So we have L21 times U13. So we have L21 times U13, and of course L21 times U13 plus 1 times U23 plus 0 times U33, so that becomes negligible. So 1 times U23, that is simply U23 plus U23. And our unknown here is, of course, the U23. We have to get this in terms of U23. A23 minus L21 times U13. So we have, what is the value of our A23 according to our matrix A23? A23 is simply 4. So we have to get the value of 4 minus the value of L21 is this 19 over 4 times the U13. Our value of U13 is negative 13. So we have here 4 minus 19 over 4 times negative 13. That should be 65.75. So we're not yet done. We're going to get A31 in terms of A31. So what are we going to do is A31 row 3 of L times the column 1. So we have L31 times U11 plus L32 times 0, that is 0. 1 times 0, that is 0. So what matters most is the L31 times U11 simply. So we have L31 times U11. So our unknown here is L31. We don't know L31, so we have to get L31. A31 over U11. The value of our A31 is this, row 3, column 1. So that is basically 8. So 8 divided by the value of U11. What is the value of our U11? U11 is equal to 4. Okay, here we have computed that, equal to 4. So 8 over 4 is simply, that is 2. Okay, and we have to get A32 again, last 2. So we have A32 row 3 of this, then column 2. So we have L31 times U12. L31 times U12 row 3 column 2 L31 times U12. So we have L31 times U12 plus, okay, plus L32 times U22. Okay, L32 times U22. And again, if you're going to go back, 1 times 0 is 0. So we have the A32 now. So what is our unknown here? I think our unknown here is L32. We don't know L32. So let's express that in terms of L32. So L32 is simply A32 minus L31 times U12. Okay? Divided by U22. And what is our A32? Our A32 from the given matrix is this. And our A32 is simply also 8. So we have 8 minus L31, that is 2, times U12. Where is our U12? U12 is 22 here. So we have here 22 divided by U22. We have the value for that. U22 is this, negative 117.5. So negative 117.5. Let me just calculate it. 8 minus 2 times 22 divided by negative 117.5. That is 0.306. 0.306 in 3 decimals. So we have computed the value for it. And lastly, we have to compute for A33. So row 3, column 3. So what we have here is that we have A33 here. Row 3, column 3. Row 3, column 3. So we have L31 times U13. L31 times U13 plus, of course, L32 times U23. Row 3 again, row 3, column 3. L31 times U13, we're done with that, plus L32 times U23. L32 times U23. So L32 times U23. Then we have plus 1 times U33, or simply plus U33. And we don't know here the value of U33. So we have to get that. So A33 minus L31 times U13 minus L32 times U23. So we have the value of A33, which is, this is our A33, row 3, column 3 in our matrix, that is 17. So we have values of 17 minus L31. Our value of L31 is this, 2. So 2 times U13. What is the value of our U13? Let's see. U13 is this, negative 13. So we have the negative 13 here. Minus L32 is 0.306 times U23. Our value of U23, we shall find U23 is this, 65.75. So 65.75. Our value of U33 should be, we just calculate 17 minus 2 times negative 13 minus 0.6 times 65.75, and that is 22.881. 22.881. Hooray! We're done with the first step. Okay, we have already know the values of L21, L31, L32, and the values for the unknowns here in the matrix U. So the second step is actually what? According to our instruction, so we have the matrix L multiplied by the matrix Y, and it is equal to the matrix C. Okay, matrix C. So what do we have here? So this will now be our second step. So we have again the matrix L, wherein matrix L is composed of 1 diagonals, and all of its upper elements of the diagonal is 0. So we have here the values of L21 from our matrix, L21, L31, and L32. So we have we have the values of that now. So we have what? L21. L21 is simply equal to 19 over 4. So that is 19 over 4. Our L31 is equal to what? Let's see. L31 is equals to 2. And our L32 is now equal to what? L32 is 0.306. Let me just rewrite this. So we have 0.306. So this will be our 1. Okay. 0, 0. This will be our L matrix. I'm so sorry. So multiply that by, notice this is a 3 by 3, okay, matrix. So we have to multiply that by y sub 1, y sub 2, y sub 3. So this is a 3 by 1 matrix. So this is okay. We can multiply it because its means are equal. And the resulting is 3 by 1 matrix, which is actually our constant. So 3 by 1, 3 rows and 1 column. So that is basically correct. What is our matrix C here? So our matrix here is a 3 by 1. So negative 1, 2, 8, 1, 1, 1, and 10. So that is negative 1, 2, 8, 1, 1, 1, then 10. What are we going to do is to multiply it. So what will happen is that in order to get y sub 1 or this negative 1 to 8, so what are we going to do? Negative 1 to 8 is simply equal to row 1 times column 1. Okay? So what will happen? Y sub 1 times 1 is 1. Y sub 1. Y sub 2 times 0 is 0. 0 times y sub 3 is 0. So definitely y sub 1 is equals to negative 1 to 8. And again, for the second one, we have 1, 1, 1 is equals to, this is row 2, column 1. Row 2, column 1. So we have what? 19 over 4 y sub 1. Okay? 19 over 4 y sub 1 plus y sub 2. Okay? We don't know y sub 2. So what are we going to do? So this became y sub 2 because y sub 2 times 1 plus 0 times y sub 3 simply 0. Okay? So we have y sub 2 here. Y sub 2, isolate y sub 2, we have 1, 1, 1 minus 19 over 4 of y sub 1, which is negative 1 to 8. So let me just compute. 1, 1, 1 minus 19 over 4 times negative 1 to 8, and that is equivalent to 719. 719. And again, computing the y sub 3, we have 10. This is row 3 times column 1, row 3 times column 1. That is basically 2 y sub 1 plus 0.306 y sub 2 plus y sub 3 simply. So in order to get y sub 3, we have to isolate y sub 3. And that is equivalent to 2 minus 2 y sub 1 minus 0.306 y sub 2. And we have the values for y sub 1 and y sub 2. We have 10 minus 2 times the y sub 1, which is negative 128 minus 0.306. Y sub 2 is 719. So what is our value of y sub 3? So we have 10 minus 2 times negative 128 minus 0.306, 719, and our value should be 45.986. So we have 45.986. So these are our values: y sub 3, y sub 2, and y sub 1. Okay, so we're down to our last step. And our last step, basically, according to our instruction a while ago, is u times x is equals to y. So u times x is equals to y. So the matrix u multiplied by the matrix x is equals to y. Okay, so this is our last step. So our u is basically composed of, again, diagonals that are non-zeros. So if we're going to look at it, we have u11, u22, and u33 here. u12, u13, and u33, of which we have already calculated the values of that. So we have u11 is equals to 4. Let me just write. U11 is equals to 4. Okay. So U11 is equals to 4. U12 is 22. U12 is 22. U13 is negative 13. So that is negative 13. So take note that the diagonals, the lower of the diagonals, lower elements of the diagonals are zeros. So we can simply put zeros here. Okay? And this value is actually the U22. What is our value for U22? Again, our values for U22 is negative 117.5. So we have negative 117.5. Then for U33 we have here 22.881. So 22.881. 22.881. Okay. Let me just rewrite. And finally, here, what is our element here? Our element here is U row 2 column 3. So U23. We're going to find U23. Our U23 is what? U23 is 65.75. So 65.75. Now these x are actually the values of what? The x, y, and z. Okay? So that is our unknowns. That is equivalent to our matrix y, of which our matrix y is this. We have gotten it. Y sub 1 is negative 128. Y sub 2 is 719. And y sub 3 is 45.986. Okay. 986. So as you can see here, we have a 3 by 3 matrix. Here, we have a 3 by 1 matrix. So we can multiply this because these two are equal. And it will produce a 3 by 1 matrix, which is this. Okay? So 3 by 1. So how are we going to do that? So first, we're going to solve for z first because that's the easiest one. So what are we going to do is simply multiply it again. Okay, let me just erase this. You have seen it a while ago. So we have to get z. So 45.986 is simply equal to, this is row 3 column 1. Row 3 times the column 1. X times 0 is 0. 0 times y is 0. Plus what? 22. Oops. What happened? Plus 22.881z. Okay, we need to get z. In order to get z, we have to divide 45.986 divided by 22.881, and we are surprised to get approximately equal na z to 2. Okay, and that should be our answer, approximately equal to z. So how about the x or the y? So we have 719, and that is equal to, this is row 2 column 1, row 2 column 1. So 0 times x is 0, negative 117.5 times y, okay, plus 65.75 z. 65.75z. We don't know the y. So what are we going to do? We are going to isolate y. So that would be 719 minus 65.75. The value of z is 2. Okay, and that should be divided by what? Negative 117.5. Okay, so we have 719 minus 65.75 times 2 divided by negative 117.5, and that is equivalent to negative 5. So our value of y is negative 5. And lastly, for our x, so we have here, this matrix is equals to negative 128 for value of x. Row 1, column 1, row 1, column 1. So we have 4 times x. That is 4x plus 22 times y. 4 times x plus 22 times y minus 13 times z. So we don't know the value of x, so we have to isolate x. So we have negative 128 minus 22y plus 13z divided by 4. Okay? So we know the values of that. Negative 128 minus 22y. Our value of y is negative 5 plus 13. The value of z is approximately equal to 2 and divided by 4. So what shall be our answer for x? We're going to substitute that. Negative 128 minus 22 times negative 5 plus 13 times 2 over 4. That is equivalent to 2. Hence, our answer for these systems of linear equation, the unknowns are, again, x is equals to 2, y is equals to negative 5, and z is equals to 2. So, this should be our answer. And that's Doolittle's method. I hope you learned something, and I hope you could try this at home. Any systems of linear equation. Well, of course, our equation here are, okay, our derivation of formulas here for the unknowns of L21, L31, and U's are only for 3 by 3. So for 4 by 4, we will be doing another multiplication here for the first step, then get the values of L and U's, and of course, perform these steps again. Okay, so thank you for listening and God bless you. This is Engineer Abat and have a wonderful day.